I think I saw it. It's actually kind of cute. Your ass. How? Well, you fucking. You suck, Cheetos. But you kept dying to Fernie. Bro, Fernie's golden. I'd rather have Fernie on my team. I'll have Fernie and Bada. I'd have Fernie and Bada. Oh, Gary kept dying. So what? Oh, shoot. Not even to hear about it. Oh, I don't know what happened. Huh? Bro, I don't know. My head just went like. Yeah, cállate, pero no sirve para nada. No, no me lo traje, güey. El bien. Pero vas a terminar hoy, Ángel.
Show me the reps.
Why was he singing that?
He just sing that on like accidentally.
Oh my God.
I was singing that.
It's so shit. I think I will With the Barbeg!
Good morning, ladies and gentlemen. Get your computers on, get logged in. We got a lot to do today if you're going to get your lab done.
I like your trim, Mr. Brad.
What's that? Good.
I like your haircut. I said that
I didn't get one. It's weird. Yeah. Last night I went to bed this morning, I woke up and my hair went back in my head.
No,
Weirdest thing. Weirdest thing.
What? Please.
You got to trim. You got to fade it up.
Actually, Christopher, all right, I lied. I did get them all cut, though. I didn't get a haircut. You know how expensive it would be to get them cut one hair at a time?
I tried $5.
Boy, still be expensive, and I definitely wouldn't trust you. Other than that, ladies and gentlemen.
Trust his cousin, though.
Eric, the MDC.
Yes.
All right. Dun, dun, dun.
I like my
Groups.
Drake presentation. It's so bad. Literally.
Is this all we learned yesterday?
The idea was to create fight over your own original social media. But like, tell me this isn't valid. Look at this. Hard work.
What was that? And then we went to
Tell me this doesn't look real.
All right. So you've got a lab to get done today, ladies and gentlemen. Your goggles are in the back where they were. If you don't have your goggles with you, I'll rent you a pair for 50 cents today. I only take cash or Venmo. Okay? I will be able to experimentally determine the empirical formula of a compound. That is our lab today. That is your learning target for the day. We are going to do a pair deck real quick. Tomorrow you will have a quiz, 2 questions on it. One, similar to the last problem on the quiz last week. The other one, ladies and gentlemen, will be taking so many grams of this, so many grams of this, so many grams of this, and figuring out what the empirical formula of the compound will be. Questions? Wonderful. Then, ladies and gentlemen, since I put the pair deck in for you, here's our first question on the pair deck. It takes too long that way. All right. So, here's what you got, ladies and gentlemen. Write me the name and the compound if this is what you got out of finding the empirical formula. So you did the empirical formula. You got your ratios. This is what you got. I want you to tell me what the name of this compound would be. And write the formula correctly, please. Yep. So this is what you got. You did all your calculations. You took the grams of aluminum you were given, you converted it into moles. Took the grams of chromium that you were given, converted it into moles. Took the grams of oxygen, converted it into moles. Then when you divided by the smaller moles, this is what you got. Aluminum 1, chromium 1.5, oxygen 6. I want to know what compound that would be. I want to know what compound that would be.
I don't know, right?
Oh yeah, I forgot.
4, 6, 8.
And the formula. That's for daughter.
Oh, you're so old.
I don't know if it's right. Definitely right.
I want to find it out. I hope I can find an excuse to extend the battery of CC.
Guys,
I'm not even going to
Got it.
that long as the weight.
Is that new?
sure.
Oh, my God. We go and remove
Yeah.
Where's my tape?
It makes sense. I don't know.
It's Friday. Monday.
Oxide? What?
Let's see what's gonna pop out. Just need someone there. Oh. Get on the secret right there.
Okay, ladies and gentlemen, if you came up with these numbers, what would be the first thing you would have to do to them?
Multiply.
You would have to multiply by 2. So we're going to multiply each of these by 2, which means 2, 3, and 12. Okay? So our formula, Al2 Cr3O12. Correct?
Yes.
There is no thing that is that formula. Now, first of all, what kind of compound is this? Ternary. Ternary and ionic. Metal at the beginning meaning ionic. 3 elements meaning it's a ternary ionic compound. Okay, find me something on the back that is close to this. What? What's chromium? What's chromate? Okay, so what does that mean for this CrO4 if it was Cr3O12? There had to be 3 of them. So your formula has to be Al2 CrO4 3. Okay? Now again, you're not going to find a polyatomic. Now, when you do this, this is the ratio in lowest terms. The problem is, okay, there are 12 oxygens here, there are 3 chromiums here, and there are 2 aluminums here. So that would lower this to 1, 1.5, and 6. It doesn't realize that this is a group. It doesn't know that when they give you the data, but we know that because we have talked about writing and naming compounds. And again, when you get to Cr3O12, we look on the back of our sheet and we try to figure out what it is closest to. CrO4. But remember, CrO4 could do what with an oxygen? To become chromite. It could lose one. It could gain one and become perchromate. It could lose two and become hypochromite. The ratio here determines which of those you are talking about. The ratio here, 3 to 12, comes down to 1 to 4. CrO4 has to be chromate. Okay? Questions? Okay, what if that were your compound? What if that were the empirical formula?
CaCO4.
Leave before it gets too smelly. Okay. All right. So do I need to take and multiply this 1 times 2? No, because 1, 2, and 4, correct? Okay. All right. So now, ladies and gentlemen, again, we're taking and we're looking for a polyatomic that has something close to Cl2O4. What would that be? Okay, but chlorate is ClO3, correct? So what could this be? This could be chlorite, ClO2, correct? Because there is nothing Cl2O4, correct? So this is the closest we can come. So because this was double that, what does that mean we have to do to these? Put a 2 by it. And again, calcium has what charge? What? Calcium. Charge. Plus 2. What's the charge of chlorite? On the back, what's the charge of chlorite? -1. Thank you. So +2, -1, we would end up with this formula. Okay? We would end up with this formula, ladies and gentlemen. So calcium chlorite would be your compound. You are going to be asked on tomorrow's quiz, when you are done with your formula, to write the formula and give me the name in the proper way, like we are talking about here. Questions? Now, you will not be asked to do this, ladies and gentlemen, but what the heck, let's see if you can do it. After determining the empirical formula of a compound, you find that the empirical formula is NO2. What is the molecular formula if the molecular formula mass is 184 grams per mole, and name the compound? So how do we go from an empirical formula to a molecular formula? Do that and name the compound.
I got it.
But like, oh wait, I don't know.
Okay. Now we need certain things to find a molecular formula. What do we compare to find a molecular formula? What two things do we have to be able to figure out how many times larger the molecular formula is to the empirical? What? Of what? Okay, we need the formula mass of NO2. Formula mass of NO2, nitrogen 14.01, oxygen 16.0, 32 and 14.01, that is 46.01. What else do we need?
The given grams per mole. Don't you have to do that?
What do you mean the given grams per mole? You need the molecular formula mass, and you are absolutely correct. That has to be given in the problem. Okay? Now, what we end up doing, ladies and gentlemen, is we end up taking and dividing this molecular formula mass here. What the heck? By the one that we found for the empirical formula mass. Molecular divided by empirical. By the way, molecular always has to be bigger. The best that it can be is the same. It is possible that the molecular and the empirical are the same formula. But if that's the case, these two numbers will be the same. So when we take 184 divided by 46, we get 4. Now we go back and multiply everything in this formula by 4. So instead of NO2, it becomes N4O8. What kind of compound is this? Covalent. Since there are only 2 elements here, we can name this covalent compound. How do we say 4? Tetra. Tetra what? Tetranitrogen. How do we say 8? Octa. Octa what? Octa oxide. Tetranitrogen octa oxide. Questions, ladies and gentlemen? There will not be a molecular formula on your test or on your quiz tomorrow. Questions? All righty. Okay, ladies and gentlemen, go into your Google Classroom and open up the determination of an empirical formula lab. Click on it and open it up, ladies and gentlemen, and it should look like this. Nope, that's not the right one. Sorry. There we go. That's the one that I want. So, our purpose for today is to experimentally determine the empirical formula of a compound containing zinc and chlorine. All right. So first of all, zinc and chlorine, ionic or covalent compound.
Ionic.
What should its formula be then? ZnCl2. We already know that. The question is, can we prove it? Can we prove that the formula for zinc chloride is actually ZnCl2? That is what we are going to do today, ladies and gentlemen. So at your lab station, already sitting on a balance, ladies and gentlemen, is what is called an evaporating dish. You are going to take that evaporating dish, you are going to go to the balance at your station, you are going to put it on there, and you are going to find its mass. You cannot zero it with this on there because we need the mass of this a few times because we're going to have different substances in it. So just find the mass of your evaporating dish. Okay? Now, also at your station is a small container with 1 to 2 grams of zinc metal already in it. So you are going to take and make observations of your zinc metal. You can touch it, you can smell it, you can observe it by looking at it. It's not going to make sounds, and it is not going to be tasted by you. You also need to make observations of the 9 molar, which is almost as strong as it can be, hydrochloric acid. Do not put your finger in it. Do not feel it. Observations need to be made on sight and smell. Okay? No tasting it. No touching it. Okay? It is not going to be talking to you. If it is, we'll get you the help you need. Okay? At least 3 observations of each of these things. If you want to give me 4, you can. After you have made your observations of the zinc, you will take the zinc out of your dish. Dump it into the evaporating dish. This little weighing boat can then be thrown out. You will go back to the balance and you will find the mass of the dish and the zinc together. Together, you will find their mass. Those go down here. Mass of the dish and the zinc. And in the end, we're going to find the mass of the dish and the salt that was created. What is the name of the salt? No. What? What is the name of the salt? Phoebe, you gave it to me earlier. When I asked you what the compound's going to be.
Sodium.
There's no sodium here.
Oh my God.
What's the metal?
Oh, zinc.
Zinc.
Chloride.
Zinc chloride.
Okay.
That's your salt. That is the salt that you will be creating in this lab. That is the salt that you will be left with, ladies and gentlemen. Now, you're going to find the mass of the dish. You're going to find the mass of the dish and the zinc. You're going to place the dish on the hot plate. And the only other time you're ever going to touch that dish from here on out is when your lab is done. And when you go to touch it, when your lab is done, ladies and gentlemen, because it will have just spent about 20 minutes on a hot plate, taking and driving off all of the water in it, I would use tongs to remove it. So you're going to take and you are going to grab an edge of it, grab it tightly, take it off the hot plate and set it on the table when you are done. And you will leave it there to cool until you can touch it and grab it with your hand and take it to the balance to find its mass. If you take it directly off the hot plate and put it onto my balance, you will owe me $1,200 because you will bend the electronic plate in there and it will be useless to me. So you set it on the table, you let it cool, you make your observations of the salt residue that is there, and when it is all cool, you put it on the balance one last time. Okay? You put it on the balance one last time. Okay? Now, when you put it on the hot plate, you are then going to begin your reaction. Okay? You are then going to begin your reaction. So, here's your zinc metal in the dish. You're going to take 2 dropperfuls of acid. And you are going to start your reaction. Now, when you put the acid in there, you want to take and kind of spray it in there so the zinc metal separates. Why? The reaction will go faster that way. So when you add your acid, now you're not spraying it at your lab partner. You are spraying it into the dish so that the zinc separates, reacts, and then it'll settle back to the bottom. When this slows down, you are going to add more. Now, here's the key. If you add too much acid, it will take longer to heat and drive off the water to recover the salt. If you go too slow, you're going to sit here forever waiting for it because the reaction is going to take a long time. So this reaction has slowed down. There is still a lot of silver in the bottom. I'm going to take another dropper full, and I'm going to squirt it in there. Again, trying to get the zinc moving around every time I squirt it in there. You're going to continue to add acid until the zinc is all gone. Now, when there is a tiny bit of zinc left, a tiny bit in the bottom, you can add some more acid and then turn your hot plate on. Okay? When you turn your hot plate on, you can turn it all the way to high. However, if stuff starts popping out and flying out, you're losing what you're trying to recover. Turn your hot plate down some. You need to keep it boiling. You don't want stuff flying all over the place. Okay? You don't want stuff flying all over the place. So again, it's starting to slow down. I would add more acid. Okay? When you are heating it, most of the time spent heating it at the start, you're going to see very little changes. It'll start boiling, it'll bubble, maybe things will pop out a little bit and you'll have to turn it down. But most of the time you're just sitting there waiting. You're like, man, is this ever going to finish? Well, here's the thing about this. When it finishes, ladies and gentlemen, it finishes very fast. What's going to happen is, as the water goes away, it's going to get kind of syrupy or almost like a thick liquid in the bottom.
Can you just say yes or no?
Yes, no.
I'm a total.
Minutes, rate 1:30, perfect.
That's what it should be.
That's the day, yes.
Okay, just making
Yes.
sure. Can you make it not stink in this room?
No, as a matter of fact, I turned on the vent over there
I turned
because
on the hood.
I was going to leave this door open so that it went between the 2 rooms.
No.
I can't do that now, apparently. Okay, so it's heating. It's starting to get thick and syrupy. Very little liquid left. You've got to pay very close attention at this point. You will literally get a white crust on the top. And that white crust will literally move up and down as the liquid underneath it is still boiling away. So you're watching it, and it's going up and down and up and down and up and down, and all of a sudden it'll just go down. And it will stop. You got to get it off the heat now. You've got to get it off the heat now. When that stops happening, it is done. Get it off the heat, set it on the counter. And let it sit there. Clean up your station, because probably stuff is going to have splattered out around it. Okay? Get ready to take your final mass and make observations of the residue. While this reaction is happening, you should be writing down 3 to 4 observations as well. Believe me, you will be able to use your sense of smell for this one, ladies and gentlemen. You will be able to use your sense of smell for this one. Okay? Questions? All right. Real quick, ladies and gentlemen. Well, maybe not real quick, but fairly quick. What is the exact mass of zinc used? How do you find that? But how do you find it? We never put the zinc just on the balance. Continue. Okay, you have the measurement for the mass of the dish. You have the measurement for the mass of the dish and the zinc, correct? So in here, you're going to show me what two numbers that you are going to subtract, and you're going to give me an answer. Okay? Then you're going to take that number of zinc, and you are going to put it into moles. How do we get from grams to moles? Not exactly building my confidence for tomorrow's quiz, ladies and gentlemen. We're going to use a formula mass for what? Zinc. No, just zinc. This is just zinc. Okay? So you're going to find the moles of just zinc. Now, again, a little bit difficult formatting here. If you want to take and do these calculations on a sheet of paper and take pictures of them with your Chromebook and put them into there, I don't care. I don't care. Or you've got to type them up. You've got time while the lab is going on. You cannot do this part, though, ladies and gentlemen, right away. What is the mass of the substance in the evaporating dish at the end? You can't do this until the lab is over. Okay? But you could get those first two calculations done. The rest of these we're going to have to talk about afterwards. Questions? Your goggles need to be worn the whole time you are in the lab. Some of you may feel the need to step out of the room because of the pungent odor that will be created. You may step out in the hall through one of the two doors that I will leave open. But do not leave your substance unattended. If you're out in the hall, your lab partner better be there watching it. And if they go out in the hall, you need to be there watching it. Again, very concentrated acid, acid that can and will eat away and burn your skin, acid that can and will leave you blind if you get it in your eyes. Now, there's no reason you will get it in your eyes. There is no reason to even pick this container up off of the counter. Take a dropper full of liquid, spray it into your evaporating dish that is on top of the balance, and you don't have to touch anything other than the pipette and turning on your hot plate. When the dish is done, the acid will be gone. You can set it on the counter. Okay? You can set it on the counter. Questions? If you want aprons, they are in the back of the room, ladies and gentlemen. Goggles are in the middle section. Stations are there. There are 23 of us in here. There will be one group of three. Hold on. One group of three. And right where Faith is going right now will be where the group of three is. So if you're in the group of three, you can be there. If not, you need to get to one of the other stations. Let's go, ladies and gentlemen. Let's go, let's go, let's go.
Yes.
Goggles on as soon as you get in the lab, ladies and gentlemen. Goggles stay on the whole time you're in the lab. If you move out, you can take them off. Does your partner know? Okay, here we go. Okay, so here we go. Right here. Set it on the counter up here, if I can please, Irving. Goggles don't do you any good when they're on your foreheads, ladies and gentlemen. I'm not worried about you losing some hair in this lab. I'm worried about you losing your sight. So put your goggles over your eyes. Nelly laughed. Nelly laughed, Dave. By the way, it would be a good idea to move your computers away from the hot plate when you start heating things, because stuff will pop out. For right now, you are fine, but when you start heating things, slide it over. Okay, hang on. You guys got to go somewhere else. Because I only want one group of three here. That's why we set this one. So you can go work at that station over there. Yeah, I know you have to work across from Josie and Phoebe, but sorry, that's just the way it works out sometimes. Alright? Now, hang on, Jack. Are you working with Olivia? Okay, then here's you and Joshua are together. Go. That's fine.
Okay. So we have to
There you go. Now we got groups of two. See? Two. One group of three. At the station we asked you to. So now you guys can slide on both sides. You get this whole area to work with. You can do either side. Okay? Either side. Okay? Do not pick up the acid. Do not move the acid. Take the dropper out. Put it into your sink when you are ready.
How big is your
Now, today is a good reason for our balances to read to the thousands place. But if you do not zero it before you begin your measurements, it will be off.